Good day, everyone. For today, we will going to talk about problem-solving approach. So what is a problem-solving approach? As the emphasis has shifted from teaching problem-solving to teaching via problem-solving, Lester, Lambdin, Dos Santos, and Raymond, many writers have attempted to clarify what is meant by problem-solving approach to teaching mathematics. So the focus in teaching mathematical topics through problem-solving contexts and inquiry-oriented environments, which are characterized by the teacher helping students construct a deep understanding of mathematical ideas and processes by engaging them in doing mathematics, creating, conjecturing, exploring, texting, and varying. Problem solving also is the act of defining a problem, determining the cause of the problem, identifying, prioritizing, and selecting alternatives for a solution, and implementing a great solution. So why is problem solving is very important? Good problem solving skills empower you not only in your personal life but are critical in your professional life. Solving problems means making choices. Typically, effective problem-solving skills result in happier, more confident, and more independent individuals. When children tackle problems on their own or in a group, they become resilient. They learn to look at challenges from a fresh perspective.
Hello everyone, so once again I'm Angel May Aranda. So this time let's going to continue on what Darwin Julian's topic. So it is the characteristic of the problem solving approach. So it includes the interaction between students and teachers, and teachers to students. One of the example is, as a teacher, you should provide a questions that is applicable in real life situation, because by this it will build a concrete knowledge towards these students. On the other hand, mathematical dialogue and consensus between students. So students will share their knowledge as well as the experiences and to speak it up based on their understanding. Next is teachers providing just enough information to establish a background intended of the problem, and students clarifying, interpreting, and attempting to construct one or more solution process. So teachers should give complex problems wherein students will come up with an idea that will help them to improve their critical and reasoning skills. And next is teachers accepting right or wrong answers in non-evaluative way. So as a teacher, you should be open-minded and flexible enough to face students' weakness. Instead, give them a space of learning in order for them to grow. So you should remember that. And the next will be teachers guiding, coaching, asking insightful questions, and sharing the process of solving problems. Yes, teachers should exercise flexible learning, like providing visual aids and any materials that is needed during the discussion. So in this case, students will be attentive to learn, of course. So on the other hand, teachers knowing when it is appropriate to intervene and when to step back and let the pupils make their own way. So not all the time the teachers will lead the students, because it is good thing, or it gives a better that the students to have a research or explore new things. Okay, so next is a further characteristic is that a problem-solving approach can be used to encourage students to make a generalizations about rules and concepts, a process which is central to mathematics. True. Because through problem solving, almost 100%, it can enhance or improve our thinking skills, or it is good thing to give us such a sample problem and students will have to find out the solution. By this, the class will be more challenging and exciting. Remember that. Okay, so those are the what? So those are the problem-solving approach.
Schoenfield described the way in which the use of problem solving in his teaching has changed since the 1970s. My early problem solving courses focused on problems amenable to solutions by Polya type heuristics. Draw a diagram, examine special cases or analogies, specialize, generalize, and so on. Over the years, the courses evolved to the point where they focused less on heuristics per se and more on introducing students to fundamental ideas. The importance of mathematical reasoning in proof, for example, and of sustained mathematical investigations where problems served as starting points for serious explorations rather than tasks to be completed.
Schoenfeld also suggested that a good problem should be one which can be extended to lead to mathematical exploration and generalizations. So he described three characteristics of mathematical thinking. First, valuing the processes of mathematizations and abstraction and having the predilection to apply them. Teachers need to make themselves vulnerable to the process of mathematization rather than to the historical content of mathematics. So they need to give themselves an opportunity to experience their own creativity. And when they are in contact with it, they must turn to their students to give them the opportunity as well. Next, developing competence with the tools of the trade and using those tools in the service of the goal of understanding structure, mathematical sense making. So there are mathematical learning tools that can be traditional, technological, or social. In that case, teachers' most frequently employed tools are traditional, which include physical objects or manipulatives. Example, cubes. Next, visualization tools. Example, function diagrams. Lastly, the paper and pencil task. Example, producing a table of values. These tools in mathematics must be developed in order for the students to understand mathematical sense making. And lastly, as Kolb et al. Suggested, the purpose for engaging in problem solving is not just to solve specific problems, but to encourage the interiorization and reorganization of the involved schemes as a result of the activity. Not only does this approach develops students' confidence in their own ability to think mathematically. It is a vehicle for students to construct, evaluate, and refine their own theories about mathematics and the theories of others. Because it has become so predominant a requirement of teaching, so it is important to consider the processes themselves in more detail.
The role of problem solving in teaching mathematics as a process. Problem solving is an important component of mathematics education because it is the single vehicle which seems to be able to achieve at school level all three of the values of mathematics listed at the outset of this article: functional, logical, and aesthetic. Let us consider how problem solving is a useful medium for each of these. It has already been pointed out that mathematics is an essential discipline because of its practical role to the individual and society. Through a problem solving approach, this aspect of mathematics can be developed. Presenting a problem problem and developing the skills needed to solve that problem is more motivational than teaching the skills without a context. Such motivation gives problem solving a special value as a vehicle for learning new concepts and skills or the reinforcement of skills or already acquired. Approaching mathematics through problem solving can create a context which simulates real life and therefore justifies the mathematics rather than treating it as an end in itself. The National Council of Teachers of Mathematics, or the NCTM, recommended that problem solving be the focus of mathematics teaching because they say it encompasses skills and functions which are an important part of everyday life. Furthermore, it can help people to adapt to changes and unexpected problems in their careers and other aspects of their lives. They see problem solving as a vehicle for students to construct, evaluate, and refine their own theories about mathematics and the theories of others.
So, according to Riznik 1987, a problem solving approach contributes to the practical of mathematics by helping people to develop the facility to be adaptable when, so for instance, technology breaks down. It can also help people to transfer into new work environments at this time when most are likely to be faced with several career changes during a working lifetime. So Resnick expressed the belief that school should focus its efforts on preparing people to be good adaptive learners so that they can perform effectively when situations are unpredictable and task demands change. So Cockcroft 1982 also advocated problem solving as a means of developing mathematical thinking as a tool for daily living. So saying that problem solving ability lies at the heart of mathematics. So because it is the means by which mathematics can be applied to a variety of unfamiliar situations. So, problem solving is, however, more than a vehicle for teaching and reinforcing mathematical knowledge and helping to meet everyday challenges. It is also a skill which can enhance logical reasoning. So, individuals can no longer function optimally in society by just knowing the rules to follow to obtain a correct answer. They also need to be able to decide through a process of logical deduction what algorithm, if any, if any a situation requires, and sometimes need to be able to develop their own rules in a situation where an algorithm cannot be directly applied. So, algorithm means a process or a set of rules for solving a problem or accomplishing a task. So, for these reasons, problem solving can be developed as a valuable skill in itself. So, a way of thinking rather than just rather than just rather than just the means to an end of finding the correct answer.
Many writers have emphasized the importance of problem solving as a means of developing the logical thinking aspects of mathematics. If education fails to contribute to the development of the intelligence, it is obviously incomplete. Yet, intelligence is essentially the ability to solve problems, everyday problems, and personal problems. Modern definitions of intelligence talk about practical intelligence, which enables the individual to resolve genuine problems or difficulties that he or she encounters, and also encourages the individual to find or create problems, thereby laying the groundwork for the acquisition of new knowledge, as well as pointed out earlier. Standard mathematics, with the emphasis on the acquisition of knowledge, does not necessarily cater for these needs. Describe the discrepancies which exist between the algorithmic approaches taught in schools and the invented strategies which most people used in the workforce in order to solve practical problems which do not always fit nearby into a taught algorithm. As says, most people have developed rules of thumb for calculating, for example, quantities, discounts for the amount of change they should give, and this rarely involves standard algorithms. Training in problem-solving technique equips people more readily with the ability to adapt to such situations.
A further reason why a problem-solving approach is valuable is an aesthetic form. Solving problems means making choices. Typically, effective problem-solving skills result in happier, more confident, and more independent individuals. When children tackle problems on their own or in a group, they become resilient. They learn to look at challenges from a fresh perspective. Problem solving allows the students to experience a range of emotion associated with various stages in the solution process. Mathematics who successfully solve problems say that the experience of having done so contributes to an appreciation for the power and beauty of mathematics. The sense of wonder, enjoyment, and aesthetic delight in mathematics are epistemic emotions. They motivate students to do more mathematics and thus help them to advance and to learn more about it. Everyone can benefit from this. The joy of banging your head against a mathematical wall and then discovering that there might be always of either going around over that wall. They also speak of the willingness or even desire to engage with a task for a length of time which it causes the task to cease the being a puzzle and allows it to become a problem. However, although it is this engagement which initially motivates the solver to pursue a problem, it is still necessary for certain techniques to be available for the involvement to continue successfully. Hence, more needs to be understood about what these techniques and how they can best made available. In the past decade, it has been suggested that problem-solving techniques can be made available most effectively through making problem-solving the focus of mathematics curriculum. In the past, problem-solving had a place in the mathematics classroom, but it is usually used in a token way as a starting point to obtain a single correct answer, usually by following a single correct procedure.
Good day, everyone. I'm Limar Satokia, and for the continuation, National Council of Teachers of Mathematics, or the NCTM, recommended that the mathematics curriculum should be organized problem solving, and it is focusing on developing skills and the ability to apply these skills to an unfamiliar situation. Yes, this skills is very important to develop, and this is the ability that we can apply in the unfamiliar situations, especially in our real life that we can encounter someday. The second is gathering, organizing, interpreting, and communicating information. So it is very important in problem solving that you can gathering data, organizing data, interpreting ideas, and communicating information, because we can solve it step by step and we can solve it quickly and we can share it how to solve that problem. So the third one is giving us how to face our problem that we can encounter in the near future and giving us an idea how to
solve it. So this is the ideas: formulating key questions, analyzing and conceptualizing problems, defining problems and goals, discovering patterns and similarities, seeking out appropriate data, experimenting, transferring skills and strategies to new situation. So these ideas, we can apply it in the real situation that we can encounter in the near future. So the last one is developing curiosity, confidence, and open-mindedness. So this is very important in problem solving because develop our curiosity is very helpful to us to get to gather a data, and develop our confidence is very important in problem solving to solve the problem without any doubt. And being an open-mindedness, we are willing to consider the answer of that problem.
Aims of teaching through problem solving. First, it encouraged students to refine and build new ideas. So problem solving help students refine and build new ideas or become creative upon receiving and giving ideas to any situations. So to make it effective, teacher must allow students to have an actual work or any hands-on activity and make sure that the activity is enjoyable, knowledgeable, and most important, it is safety because young learners is adventurous and are in the stage of curiosity. So it must be enriching ideas by experiencing, making hypotheses, investigation, and discover the reality. So next one is developing knowledge. So when students develop knowledge, they are also developing understanding and awareness. So it will improve critical thinking skills and confidence. So as a soon to be a mathematics teacher in elementary grades, you are responsible to help your students become flexible, creative, and self-directed learners. So your aim in teaching mathematics is more than to what your students need. So third one is more responsible for their own learning. So teacher will in charge to encourage and lead students to be responsible individual in how and what they learn. So teacher should expert to handle individual uniqueness and should use and apply multiple methods and strategies to open all the possibilities upon teaching mathematics. Open the main idea, investigation, result, and evaluation to open the mind of the students. In that way, they become open to learn something new and responsibly learning easy to complex problems and information. Next one is students need to develop their own theories. So students who involve problem solving will develop his own set of ideas, so it is needed a proper support and helping hand. So installing techniques and strategy is necessary. That is why teacher needs to be flexible enough and more creative than learners in terms of giving or taking ideas and informations. So factuality is a must. Teaching is not about sharing ideas, displaying information, and imparting knowledge. It is also managing and determining students' strengths and weaknesses. By that, teacher can easily determine and foster the needs of individual. So next is students can become even more involved in problem solving by formulating and solving their own problems and encourage students to discuss the process which they are undertaking. So by identifying and articulating problems and ideas, problem solving is active in this area of learning. It will help learners open to solve complex problems, open and adapt new situations. All in all, the aims of teaching through problem solving is to help students become independent, creative, confident, encourage greater understanding, and most of all, develop lifelong learning skills.
Hi everyone, good day. I am Rachel Maydolfino. So this video is about the rule of problem solving in teaching mathematics as a process. So conclusion. So it has been suggested in this chapter that there are many reasons why problem solving approach can contribute significantly to the outcome of a mathematics education. It can also provide the students with a context for learning mathematically knowledge. Also, it can enhance the students to transfer their skills to unfamiliar situation, and it is an aesthetic from itself. Problem-solving approach can provide a vehicle for the students to construct their own ideas about mathematics and to take responsibility for their own learning. Problem solving allows students to develop understanding and explain the process used to arrive at solution rather than remembering and applying a set of procedures. There is a little doubt that the mathematics program can be enhanced by the establishment of an environment in which students are exposed to teaching via problem solving. So, as an opposed to more traditional models of teaching about problem solving, the challenge for the teacher at all levels is to develop the process of mathematical thinking alongside and the knowledge and to seek the opportunities to present even routine mathematics tasks in the problem solving context. So once again, I am Rachel Maydolfino. Thank you.